Hi folks, it's Gregor here. You're watching Not Only Code. Today I'm going back to the idea of good code and I will give you a few other characteristics, a few more granular characteristics about good code so that you can treat them kind of like a checklist, and when you look at your code you can just go through that list and see whether your code follows all these guidelines. Okay, so today I've got 4 characteristics of good code that I want to present, and for each of them I will show you some examples, some bad examples and some good examples. The first characteristic is honesty. An honest person is a person who tells the truth, which means that person doesn't lie, but also honest person is a person that tells the whole truth, as in he or she doesn't hide any relevant facts. And I think that this definition can be applied to code as well. Good code doesn't lie about its intent, it tells its true intent, and good code doesn't hide what it does. So in this example, we've got a class called user with just one method called find. And when I look at this class and this method, I imagine that what this method does is that it finds a user based on certain conditions, which in this case is the ID of the user. And if there is no such user, if there is no user with the provided ID, I assume that this method will either raise an error or it will return me something like null, depending on the language in which it is written. So let's have a look at the method on the left. What it does is that indeed, first it checks whether there is a user with certain ID in the list of all users, but if there is no such user, this method will create a new user. I think that this method, maybe it doesn't lie, but it doesn't tell the whole truth. The name of the method doesn't tell me that it will create a new user. It will return a new user if the user that I want is not found. So if we want to make this code honest, we have 2 options. First, we can rename this method. Let's call it find or create, find or new, find or build. Something that tells us that if this user is not found, then a new user will be returned. Alternatively, we can change the method body so that it only finds a user. It does not create a new user as a fallback. And then we can have a separate method called create or build or whatever, and we will use this as a fallback outside of the find method. And the last example shows a method that does something completely different than what it says it does. We have a class called user, we have a method called create that takes an email and a password, but what this method does is it returns a first user from the list of existing users, which is ridiculous because it does something completely different than what it says it does. So in this case, this code is not honest because it lies about what it does. The method name says I create a user, and the method body says I return existing user. I'm using this extreme example here, but in real life, the examples are more subtle. They are not so obvious that the method doesn't really do what it's supposed to do. Sometimes it takes us a while, especially if the method is more complicated, to go through the whole body, to understand it, and to realize that actually what it does, it's not what it's supposed to do. And again, the solution here is to determine what actually do we expect from this method. If we expect it to return the first user, then we should rename it to return first user or fetch first user. And if this method is really supposed to create a new user, then we need to change the body to fix that. Second, I believe that good code, well-designed code should be concise. And by concise, I mean it should not be unnecessarily long. There's always some kind of a balance here. Is 5-line function too long? Is 500-line class too long? That all depends on what your code does, on how independent different parts of the code are, on what language you are using. If you use some very high-level language, like for example Python, probably your functions should be 10 lines of code or shorter. If you're using some lower level language like C, then a function that is 40 lines long is totally expected and is very, very common. But code might be too short, your functions might be too short. If you try to squeeze something in one line that will be 200 characters long, that might be the opposite of good code. If you shorten the name of your variables and instead of user, you call the variable u, instead of calling the variable total order price, you just call it p. That's ridiculous, and that's not good code. That's not concise code. That's just some extremely bad naming. Again, let's have a look at an example here. We have one function that we're looking at. The function is called total price, and it takes one parameter called order. The function is supposed to count the price of all the products, all the elements of that order, and return the total price. In the version on the left, we assign a new variable or override variable in almost every single line. So first we define the variable items, then we actually turn items into a collection. Then we have a new variable called prices that represents a collection of prices for each item, where we multiply the price of a single item by the number of items of the same type that user is buying. Finally, we have a line that is called total price, where we just sum all the prices and then we return the total price in the last line. For me, this code is unnecessarily long because it can be done in a shorter, more concise way without sacrificing the readability. On the right, we have the same function that does the same thing, but it's shorter. And I think this lack of explicitness, this lack of defining a local variable in every line actually makes the code more readable. So in the first line, I already know that I will return some value. Then we are turning the items of the order into a collection without defining a new local variable. Then we're chaining methods. So we call the same map as before, and then we call the same reduce as before. So I know that in the map we are multiplying the price of an item by the number of items of the same type bought, and then we reduce it to sum the price. And I already know that we return this value because return is really the first word in the body of that function. The third attribute is that the code should be unobtrusive. Or in other words, the code should be well separated into different layers. As an example, let's think about the MVC framework, where M stands for the model, which deals with the data, V stands for the view or the templates, which is what we return, how we format the data, and C stands for controller, which is the web layer that deals with the requests and responses. In well-designed, well-separated code, different layers will be dealing with different concepts and they will not mix these concepts. So for example, controller will be dealing with the concept of HTTP codes, HTTP requests, the parameters, etc. Controller will be dealing with views, will be generating them, and it will be calling some operations, some business logic layer. That business logic layer will be dealing with some data. So it will be using the model layer, which will be connecting to the database or some different data source. Now, each outer layer should only deal with the layer that is directly nested inside it. That means that the views shouldn't be dealing with the business logic. It also means that the data layer, the model layer, should not be even aware of the existence of the controller. The model should be so separate that I could technically take it out of my web application and put it into desktop application. And it should work. It shouldn't be depending on the presence. It shouldn't be depending on the concept of the web. Let's have a look at some code example. In this case, we have two classes. The first one is called user controller and the second one is called user. The first one represents the controller layer while the other is the data, the model layer. Now my user controller has one method called handleRequest that takes the request object, and then it has just one line body. It says return user.handleRequest. Then the user class has a method called handle that, depending on the HTTP method that is used to create this request, to make this request, it either creates a user and returns a certain view related to that, or it finds existing user and again it returns the relevant view. If you're looking at this code and you're thinking, what the hell is that? You're absolutely right. I totally agree with you. This is ridiculous. The model layer should not be aware of the concept of the request. It shouldn't check whether the request is post or get. This shouldn't be the job of the data layer. Also, it shouldn't deal with the view. It should be the controller that takes the data from the model and passes it to the view. The model and the view shouldn't be really aware of each other. So on the right, we have a better solution. We still have just one handleRequest method, but that method in the controller checks whether the request is post or get. And then, depending on what it is, it calls handleGetRequest or handlePostRequest function in the same user controller class. Now, if it's get, then we just call user.find. If it's post, then we call user.create. And you can see that controller is responsible for returning the proper views. Also, the controller is responsible for passing the correct information to the model. We're not passing the call request. We just pass the relevant attribute. We pass the relevant value from the request that is needed either to create or find the user. The second solution is much better, even though it's longer. That's because I know that the user model deals only with the data. It doesn't care whether we are making HTTP post or GET request. It doesn't even care whether we are making an actual request. I could add a CLI support for this class, and I could just call the user.create or user.find from my console without having to create some fake request object that is necessary to find or create the user. The last attribute I want to talk about today is consistency. I believe that consistency in the codebase is one of these things that significantly lower the cognitive load of having to read and understand the code. Programming is a complex activity. Reading the code, trying to understand what the author of the code meant, is challenging. Dealing with inconsistent code adds to this complexity, adds to this difficulty. So having consistent code helps to remove some of the unnecessary obstacles. The consistency comes in many ways. And one example is naming. Consistent naming of classes, functions, variables, libraries, applications. It is already a good step. Then consistent handling of some errors, consistent handling of the same problematic situations that can arise, consistent handling of things like logging, observability. All these things, the more consistent they are, the easier it is for the developer to work with this code base. You might have some very strong opinions about certain code formatting or idioms. You might have very strong opinions about camel case versus snake case, about raising an error versus returning null. I know that it all matters, but it matters so much less than having consistent code base. Consistency in the long term matters much more than any single decision made. Let's have a look at the last example here. So you've got two classes, user and product. Both classes have one method called find. Since both classes are kind of data classes, they are the model layer. And since both have the same method, I expect them to behave in the same way, but they actually don't. The first difference is in the parameter. The parameter name is ID, but in the user class, this is a positional parameter. So I will just say user.find and provide the value of this ID. while in the product case, this is a named parameter. So when I call this method, I need to specify the name of the parameter. The second difference is that if the user is not found, the function will just return null. While in the product class, if the product is not found, then an error will be raised. And let me tell you, it is a nightmare to work with such code, especially if you don't have just 2 classes, but 200 classes to deal with. How do you remember which class will raise an error, which class will return null, which class takes the name parameter or the positional parameter? You have to always check the body of the function, the definition of the function. You can't remember it. Once again, consistency is the key. Just pick one option, whichever it is, and stick to that. In the long run, it will be a great help to keep your code base consistent. And the last thing that I want to mention today is that good code is easy to modify. This is something that I had already mentioned in one of the previous episodes, and I just want to reiterate that because it's extremely important. When you finish writing code, or when you review someone else's code, you should determine whether this code is easy to modify in the future. And besides these characteristics that I had mentioned before, I want you to have a look at this code and ask 3 questions about it. First, is this code easy to understand? Code can't be easy to modify if it's not easy to understand. Second, is this code easy to navigate? Because we can't easily modify the code that we can't easily find. And lastly, is this code easy to test? Because we can't easily change what we can't easily verify. I believe that answering these 3 questions makes a huge difference when it comes to determining and maintaining the quality of the code. Alright, that's it for today. Remember that maintaining the quality of the code is not a one-time thing. It's a chore. You have to keep doing it, because if you stop at some point and the quality of the code decreases, it is very hard to bring it back to the same higher level. I'm sure that I will be coming back to the topic of good code in the future, because this is such a broad concept and there are so many different techniques to improve the code. In the meantime, in the next episode, I'm going to focus on something completely different. I will be talking about improving your communication skills. I want to share a bunch of lessons that I have learned over the years that I believe were critical to improving myself, to improving my skills and my position as a software developer. It will be an interesting episode and I hope to see you then. Stay tuned.